Now, is it visible on your screen? Hello?
Yes, ma'am.
So write down this first, preparation of Prussian blue, and then this part. First of all, write down only this part. Total equation I will explain you, but write down only this part right now. Till that time, I am allowing other students to join the meeting. Okay, let us start. See, as far as I know, you must have already know what are inorganic preparations. Basically, inorganic preparation in your syllabus is the preparation of metal complexes, right? Now, the word Prussian blue is just general name for a complex which is made up from the iron. So as you can see right now in this equation, it has been mentioned that iron, that is Fe, is converted to its another complex which is ferrocyanide. Now if you look at the equation, you can easily identify it is similar structure to potassium ferricyanide and ferrocyanide. In laboratory, you normally use the solution potassium ferricyanide and potassium ferrocyanide. So what is the difference between ferro and ferri is the valency of Fe in the complex K4FeCN6, for example, you will consider, then we say it is a potassium ferrocyanide because K4 stands to stabilize -4 valency left out with the cyanide due to the positive 2 oxidation charge of the ion. Similarly, here the structure is Fe4FeCN6. That means it is iron ferrocyanide. So the chemical name of this compound is iron ferrocyanide, or we can say ferric ferrous ferrocyanide, potassium ferrocyanide, just like ferrous ferrocyanide. But normally we are not using the word ferrous or ferric just to avoid a complication. We just say it is an iron ferrocyanide. Now, inorganic preparation, whenever you have to start with, normally you will be asked to write down the equation for the particular preparation. Now, this equation here, what we have mentioned, is just a Fe molecule, that is one Fe atom. When converted to iron ferrocyanide, what is the molecular weight? Because right now here we are concentrate on the weight of a starting material and weight of our product. So that's why we have considered here only Fe and iron ferrocyanide. But what is the actual preparation? Actual preparation is to convert the iron from Fe plus 2 to Fe plus 3 with the help of sulfuric acid, and then we are treating it with the potassium ferrocyanide. So there will be a substitution of potassium molecule with the iron molecule. So now we are going for our actual process of preparation. So starting with our requirements. Our requirements are iron flakes or iron fillings. Iron fillings means it is a iron particles, we can say in general. So we have to consider that iron particles or iron pieces. Then we need potassium ferrocyanide, and then we need ethanol and alcohol. So in process, we will dissolve this iron particle in the sulfuric acid first. For any inorganic preparation, it is important that how you are performing the practical, because given method is the general method everyone will follow. But when you will perform the practical, you will be able to find that for one students, they will get a good product, whereas the other students may not be able to get the good products. And that is just because of how you are handling with the chemicals, how you are adding the substance or solution, and how you are performing your practicals. That is most important part. So given here is what are the requirements, which instruments we need, and how to perform the practical, that we will discuss. For this particular practical, I will discuss everything in detail. Then for other practicals, I will share some videos which is available with me. We have downloaded from the YouTube with when your syllabus has been generated. At that time, we have discussed this part, and we have shared the videos with other faculties also. Now, iron fillings, just a picture. It may not be like look like this. It may be a brown pieces, it may be dark brown or whatever. But the iron pieces will be there. Iron fillings, normally we will consider it very small particles, so it can be easily dissolved. Or you can say it can be a powder also. So particular weight of this iron fillings we will measure, and then we will take the other solutions for our practicals. Requirements are what? Apart from these chemicals, what we other require? We will require beaker, funnel, measuring cylinder, glass rod, watch glass. Obviously, here it is not mentioned. We need a burner also, tripod stand also, filter paper also, because we want to filter sometimes we need to filter the solution, sometimes we need to decant it. So beaker also will be more than 2. We will require more than 2 to 3 beakers also. Maybe the size of the beaker may vary, either it may be 250 ml, it may be 100 ml, whatever it will be there. But in general, we use 250 ml or 400 ml beaker, because whenever we have to boil the solution, the 250 or 400 ml corning glass beaker will be very much useful, and they are safe to perform the practical also. Now, going to the method of the preparation, we every time for any preparation, we will define particular weight of our starting material. So our starting material is iron fillings. So right now, here I have mentioned what will be the amount of iron filling we will take, that is 0.5 gram. We require 10 ml dilute sulfuric acid. So first of all, we will collect all our requirements. 10 ml sulfuric acid, that means we have to keep ready the bottle of sulfuric acid. We have to keep beaker ready. We have to keep filter paper. make a cone of filter paper and put it in a funnel also. We required wire gauze to heat the beaker and our burner and tripod stand. All these things we required, so we will collect it all. Then we will weigh the iron fillings. We will take that whatever weight we have taken, that we will take in a beaker. Then we will add 10 ml dilute sulfuric acid to it, and we will stir the solution with the help of glass rod, and then we will heat it. Now, when we heat the solution and when we are using sulfuric acid, we should be very careful because very hot sulfuric acid should not be anytime came into contact with the water. Otherwise, there will be a explosion will take place, and the splitting will be there. So you will be affected by it, and it will be harmful to your skin also. So be careful about it. So handle the solution very carefully and put it every time. You have to use a asbestos sheet also. Asbestos sheet, that is heat resistant sheet, which will be very useful when we are dealing with a hot burner or anything which is hot, and we have to keep it on the table so that the surface will not be damaged. Now, when we dissolve this iron particle in sulfuric acid and heat it, most of the particle will be dissolved, but we are not very much sure that either the almost all the particles will be dissolved or not. So what we will do, here I am showing you another thing which has been mentioned in the diagram. Take 0.5 gram iron fillings in a beaker, add 10 ml sulfuric acid, heat it on a wire gauze. As soon as the reaction becomes vigorous, remove the... Now how will you identify the reaction becomes vigorous? That means your solution will start boiling, or you will find a very instant change in the color of the solution also. Sometimes you may identify the change in the color. Sometimes you will find that as soon as that iron fillings will be dissolved, the solution will look like a transparent or clear solution. So at that time, you have to remove the beaker from the burner, cool it at the room temperature only. So put it on an asbestos sheet. Then, when the solution becomes little bit cool, we have to decant and superlatent liquid. Decant the superlatent liquid means if any part of iron filling which is insoluble, which is unreacted, it will be there in a beaker. So while decanting the solution, we will take the upper part of the solution in another beaker, and the remaining iron fillings, again we will add a sulfuric acid slowly with the continuous stirring, and we will try to dissolve most of as much as iron filling will be dissolved in it. So that's what we are saying in our preparation method also. We say that dissolve the iron fillings, heat it on the wire gauze. When the solution becomes cool, filter it, and if needed, repeat the step 1 and 2. If needed, repeat means if there is some part insoluble, then add the sulfuric acid as in the step 1, heat it again, and again filter it. Now, once you have clear solution of iron filling which is soluble in the sulfuric acid, or which is already reacted with the sulfuric acid, that means now what is the purpose of use of sulfuric acid? Why we are using it? Simple thing. When we are taking iron fillings, that means a powder of the metal, the oxidation number of the metal will be different in that powder, and oxidation number of our reagent will be different. So some of the particle may be converted to the Fe+2, but some may also at the same time converted into Fe+3. Now actually we want to convert all the Fe particles in the +3 oxidation state. So here, after the first and second step completed, sometimes, not every time, sometimes we add nitric acid and boil the solution little bit so that all the ion will be converted to the ferric state. That means Fe plus 3 state. And the solution become yellow. So now all the Fe particles, Fe atom will have plus 3 oxidation state in this solution. Our next step is the reaction with potassium ferrocyanide. For that, what we have to do? Potassium ferrocyanide also will be used in a solution form. So we will take 4.5 gram of potassium ferrocyanide and we will prepare saturated solution. Saturated solution means very little water should be added to the substance, and with the continuous stirring, as soon as the substance dissolve, stop adding the water. And normally when we prepare the solution, we use warm water. So please remember, for any inorganic chemistry preparation, whenever you have been told to prepare a solution, you have to use a warm water. So heat the water separately and then use that warm water to dissolve your substance. Once the saturated solution of potassium ferrocyanide will be prepared, use this solution to react it with the our solution of ferric ion. So now whatever solution of ferric ion is there, we will use this our saturated potassium ferrocyanide solution. We will add that solution into our beaker slowly and with continuous stirring, and when all the solution will be added to the solution of ion, then we will boil the solution. Now, while boiling the solution, the reaction will be occurred. Potassium ferrocyanide will react with our ion elements, and the ion elements will substitute the potassium ion from the complex and it will take place of it. So our ion ferrocyanide substance will be formed. How it will be identified? When you will start the boiling the solution, color of the solution will be little bit yellow, but as soon as the reaction will forward it will attain the completion state, your solution will become green color solution. So your green color solution shows that the reaction of the ion filling solution and potassium ferrocyanide has been partially completed, or you can say the first stage has been completed. Now to complete all the reaction, we need air or oxygen. How we can provide the air or oxygen? In general, we have blower. So we can use the air blower or we can use the blow pipe. So blow pipe when you are using, otherwise you can use the hollow tube also. With the help of your hollow tube, you have to blow the air through your mouth to the beaker of this solution. Now remember, we have boiled the solution and therefore the solution will be very hot. So while blowing the air in the solution, we should be very careful that it will not spread out of the beaker and the sprinkle will not came out of the beaker. So start blowing very slowly, and as mentioned in the procedure, we have to blow it for some 10 to 15 minutes. The time may not be written over here, but the blowing of the air should be at least 10 to 15 minutes. After the blowing of the air for 10 to 15 minutes, we have to keep the beaker in the air for about 2 hours. So if we want to reduce the time to keep the beaker in the air, that means atmospheric air will react with the solution and complete the procedure. If we want to reduce that time, we have to blow the air for more time. So instead of keeping the 2 hours time and stand by, we just normally follow, pass the air through it, that is blow the air for at least half an hour. So when you will do this process, what will happen? Fine particles of your product will start forming. So air is working as a catalyst for this solution, for this preparation. In another preparation also, you may find that air is required and we are using that type of blowpipe. So to complete this procedure as early as possible, we are using the air, and that's why we are blowing the air through our mouth or through the hollow tube. Once the product will be completed, once the fine particle of Prussian blue will formed, what we have to remember again, normally we use water to wash the product, but in inorganic preparation, we have to always remember that we are preparing metal complexes, and when we are preparing the metal complexes, normally all the metal complexes are soluble in water. What that's what we have discussed in our earlier lecture also in the class. So here, to wash our product, we are using alcohol, that is particularly ethanol. So we are using ethanol to wash our product. So ethanol will serve two purposes. Number one, it will not dissolve our product. And number two, when we are using ethanol, our product will be easily dry up and we will have a pure crystal of our product. Now, once the solid product will form, washing with the ethanol, that means you add the ethanol in the beaker so that your product will be settled down and another remaining solution will be separated out. Then we have to filter it with the help of funnel and filter paper. Once the product is filtered out and it will be separated from the remaining solution, dry it. Dry it means we should not press any pressure. We should not put any type of pressure on the product. Just take another filter paper and take out your filter paper from the funnel, open it up and take it in your palm. Take another filter paper and put that filter paper on your product and press very slightly. Don't put more pressure on the it. Otherwise, your crystal will be broken out. So, very politely, you have to press that filter paper which you are using to dry your product. If it will become wet, take the other part of that filter paper. So all the side of the filter paper of the top filter paper, you can use one by one and try to dry your product. You can use second filter paper also for the drying, but without more pressure. Once your product will be dried, we will take it and we will find out the weight of the product. Now, our type of our product, that means how it looks like and what is the yield of the product, that is used over here to find out the percentage yield, and to first of all to find out the weight of our product. With the weight of our product, we can find out how much percentage of Fe are converted into our product. That is the main concept of the calculation of the percentage yield. Now, look at this equation. Initially, we have taken 0.5 gram of iron fillings, and when we weigh our product, we will get dash gram. For example, you are getting 12 gram of your product. So here you will have 12 gram right now. For the equation, calculation of the percentage yield, what we are using, what we are doing, you have weight of the Fe, that is atomic weight of the Fe, and molecular weight of iron ferricyanide. Considering with this one, if weight of your product is 859.25 gram At that time, how much Fe you are using? 55.85 gram of Fe. Now we have used how much gram of Fe? We have used 0.5 gram of Fe. So theoretically, we have to calculate first that out of 55.85 gram Fe, we will obtain 859.25 gram iron ferrocyanide, that is Prussian blue. Then how much yield, how much product should I get with the 0.5 gram Fe? So that's what we have calculated over here. 7.6 now gram, that is our theoretical yield. If I have to find out what is the practical yield or percentage of yield, then what we will do? We will use the weight of our product. Whatever product of your practical yield will be there, you have to consider that part over here, that is experimental yield. Then it will be divided by the theoretical yield, which we have calculated over here, and multiply by 100. That will be the percentage yield of your product. Now for any preparation, you have to remember particular two things. Number one, whatever you are using as a raw material. And number two, what are the product you will obtain. Now this is not the one step solution, as we have used first of all FeSO, sulfuric acid. So it has reacted with Fe. So first reaction will be obviously the reaction between iron fillings and the dilute sulfuric acid, which will give you the solution of this one. Then we are using little bit of HNO3. That means initial whatever your product is there, solution is there, Fe plus 2 will be converted to Fe plus 3. Then that Fe will be converted to Prussian blue. So step by step reactions are there, and therefore the equation also will be according to it. But only we have to remember what is our starting material for each preparation. For this one, it is a iron filling, which is a starting material, and end product is Prussian blue, that is iron ferrocyanide. So for every preparation, you have to use the atomic weight and molecular weight of these two, starting material and end product. Now, one question will be here for what is the use of Prussian blue? So as mentioned over here, it is a pigment. Now what is a pigment? Can you tell me? What do we mean by pigment? Or what is the difference between pigment and paint? Anyone? Do you have any idea what is the difference between pigment and paint? Now write down the question for this preparation first. Question number 1. The same. What is the difference between pigment and paint? Number 2. What is the function of sulfuric acid? What is the function of sulfuric acid in the preparation of Prussian blue? Number 3. Chemical formula of Prussian blue. Number 4. For this one, equation for percentage yield equal to, equation of percentage yield equal to, dash. Next question. Why we are using flow of air? Why we are using flow of air for the preparation? Or you can write another way, how we can provide oxygen, how we can provide oxygen in the inorganic preparation. Okay, I have given few example of it. What type of question can be asked? Sometimes you may be asked to complete the equation also, or you may be asked that which of the following equation is correct, that you have to select from the given options of the equations. Okay, now come to the next second preparation. That is preparation of chloropentamine cobalt 3 chloride. Chloropentamine cobalt 3 chloride. See, the screen visible on your part, I have highlighted a molecule. Now, how to remember the formula of this one? Here we have written chloropentamine. Chloropentamine stands for this chlorine, which is in the square bracket. So, name of the complex starting with the negative element, then there will be neutral ligand, and then there will be a metal element which is there in a complex. So chloro, that is one chloride is here, pentamine, this 5-amine molecule, cobalt, acid. Now 3, what is 3 stands for? Here these 3 represent the oxidation number of the cobalt, center atom you can say, because when you draw the structure, this octahedral structure will have cobalt as a center atom. So here chloropentamine cobalt, cobalt is a center atom. Its valency, that is oxidation state, is 3. Now here only one chlorine is there. That means there is 2 negative charge remaining on this metal complex, and 2 positive charge remaining on this metal complex due to the +3 oxidation charge. And to balance that +2 oxidation valency, here there are 2 chloride atoms over here. That chloride is represented at the last. So out of the square bracket, that is coordination sphere, that is a chloride which balances the oxidation number of this metal complex. Now, if you remember the structure of potassium ferrocyanide, potassium is written out of the bracket, but it is written as a first. So, there is a rule that if metal complex has negative charge, and to balance the negative charge, if we are using any positive element, it should be presented first before the complex. And if any metal complex has a positive charge, which will be balanced by any negative element, that will be represented after the metal complex. So name itself mentioned over here, chloropentamine cobalt 3 chloride. So now you can easily remember this structure. This preparation, this product is prepared from cobalt chloride. Now, the cobalt chloride again is a reacting material. Reaction in general, this is a whole reaction represented over here. Cobalt chloride, ammonium chloride, ammonia, H2O2, what we are using in the reaction, and this is our product, and this is a water molecule. So when we have to calculate the theoretical yield, you have to use this molecular weight of cobalt chloride 6H2O. So you have to consider molecular weight of cobalt chloride 6H2O, then molecular weight of your product, that is chloropentamine cobalt 3 chloride, and then whatever starting material you are using. How much gram? We are using 1.8 gram. So that 1.8 gram will help you to calculate the theoretical yield of your reaction of your product, and then you will be able to find out the percentage yield with the help of the weight of your actual product. Preparation as mentioned over here, for this one, we are say every time we are using a little amount of water, that is as much as required. Then whatever solution we need to complete the procedure or we need to add, we have to prepare its solution separately. So here as mentioned, slurry of ammonium chloride. Slurry of ammonium chloride means when we are using other than water, any other liquid or any other solute other than water, it is known as slurry. So here we are using ammonia to make a paste, we can say, or slurry of ammonium chloride. So we will add ammonia into ammonium chloride. So it will become a slurry type of material. So that means it is not actually a solution. It will be little bit thick, paste like material will be there. Then we will add our solution where we have used the cobalt chloride and dissolved in minimum amount of water. We will mix both of them and then we will stir it very well. Then we will use hydrogen peroxide. Here it is mentioned that 1.1 ml 30% hydrogen peroxide. So 30% means what? If I will take 1 ml of hydrogen peroxide, so I have to add remaining part of the water, mix it well, and then it will make a 30%. That means in 100 ml, it will be 30 ml. In 10 ml, it will be 3 ml of hydrogen peroxide. That will make it 30% solution. And out of that, we will use around 1.1 ml or maximum 1.5 ml. So that is also a minimum quantity of hydrogen peroxide. Here again, that's the mention that we will use or we will add this solution drop by drop. Why we have to add it drop by drop? Because the complete reaction should occur, and that's why we have to add it drop by drop with continuous stirring also. Here that is vigorous stirring. Here the word used stirring vigorously. That means continuous stirring. When you add the solution of hydrogen peroxide to the solution of your cobalt chloride and ammonia, you have to keep stirring on it and then you keep on drop by drop adding the hydrogen peroxide. Then we will heat the mixture on the steam bath. Now steam bath, how I will have? We can use our normal water bath where the steam will be there and we are using that one, but at laboratory it is very difficult to get a steam bath. In our home we can usually make it with the cooker, right? Your mother is using the cooker to cook your vegetables, or sometimes it is there, but here there what we are using, we are not heating any solution directly, or we are not keeping it in a water where the solution will be immersed in it. So your solution will be above the liquid water level, and as the water will be heated, the steam will be coming out, and that steam will pass the heat to your solution. That is steam bath. So when we have to prepare our steam bath at normal laboratory, we have to use our water bath, cover it with a lid, and your beaker should be in such a way that solution should not touch the water. That is a difference between water bath and steam bath. When we see it is a water bath, that means your solution should immerse in the water. So beaker should be in such a way that water should cover the outer part of the beaker where up till the solution is there. And when steam bath, we are saying that means water will not touch your beaker. That is only the difference. Now, during the reaction, the color of the solution will change, and with the help of that, you can find what is the stage of your preparation. With the change of the color, you will be able to identify the process. After that, follow the complete procedure. We are using hydrochloric acid, and again we will heat the solution for 10 minutes. Then you will cool it down and then filter it. Sometimes Buckner funnel will not be available every time in a laboratory. So at that time, we can use a fine filter paper, or you can say Whatman filter paper, and then filter it very slowly with the help of glass rod. So you will pour the solution on the glass rod, and then glass rod will be slowly in such a way that solution will pour in the funnel very slowly. Then same way, from as per the previous process, you can use the ethanol to wash it out, and then you can dry the product and you can weigh it. So now this second preparation I have discussed very fast, very, I can say, without any picture. We have just discussed. I will share the process with you, and the whatever video is available for with me, I will share it with you, so you can go through that one and you will properly understand how the preparation will take place, at what stage, and every time what you have to remember. And as I have mentioned, for the few questions for the first preparation, now you will be able to find out the question for this preparation. In during the examination, you will get 4 options, and you have to find out the right options for this one. So when you will be able to remember, you will go through the process, it will be easier for you to find out the right answer from the given options. Okay, now today I will conclude my lecture with these 2 preparation only. If possible, I will try to conduct one more lecture on site tomorrow or day on the Monday. As far as possible, I always try my best to discuss it on tomorrow lecture. But if it is not possible, I will sure discuss it on Monday before your examination. Do you have any question or query for this one? So I believe everyone has properly understood the process of these 2 inorganic preparations. Okay. Bye for now.